Hi everyone. Assalamualaikum warahmatullahi wabarakatuh. Today, my friend and I will explain about the solution for tutorial 5 and 6. For your information, my group members consist of 3 person, which are me, Nelisa Nur Shafira, Nur Emilia Natasha and Muhammad Afan. Okay, for the first question, we choose for in tutorial 5, question number 5. Consider the state in which L equals to 4 and S equals to 1/2. For the state with the largest possible J and the largest possible MJ, calculate the angle between L and S, the angle between ML and MS, and the last one, the angle between J and the positive J. Okay, let's look at for the solution in this question. First, we list all the information given. For L equals to 4, S equals to half. So, to get the largest J, we need to add 4 by half equals to 9/2. The largest MJ, J equals to 9/2. To find the magnitude of vector, we use the formula and we get the magnitude of vector. This is the diagram that shows the vector that consists in this solution. For A, we use using law of cosine to find the answer, and the answer theta is 58.91. So the theta is 58.91 is angle between L and S for maximum IJ and JZ. For B, the answer is since ML is parallel to the negative L and MS is parallel to S, the angle between ML and MS will also might be the same, which is 58.91. Okay, for the sixth question, we continue to find the angle between J and positive Z axis. So, to find it, we need to cos theta equal to JZ/J. So, we anti-cos the value and we get 25.2. So, let's proceed to tutorial 6, question 4. This is the diagram that have in this question. So, for the A question, from information contained in figure above and figure in question 1, determine the energy required to remove the remaining electron from the ground state of a singly ionized helium atom. Compare this energy with the energy predicted by quantum mechanics of one electron atom. So, the solution for this question is, for A, from the figure, the ionization energy for the first electron is 24 electron-volt. In the ground state, the energy of the atom is negative 78 electron-volt. Thus, the energy after the first electron is removed, we need to add it by negative 18 plus 24 equals to negative 54 electron-volt. The energy with the both electron removed is 0. Thus, the energy needed to remove the remaining electron is 54 electron-volt. For B, the solution, the answer is with the first electron gone, the helium atom resemble a hydrogen atom if Z equals to 2. For such an atom, the ground state energy will be E1 equals to Z square multiplied by E. So, we have 2 squared multiplied by negative 13.6. The value is negative 54.4 electron-volt, and therefore 54.4 electron-volt are required to ionize it.
Hi everyone, I'm Nur Emilia Natasha. So for today's video, I'm gonna explaining about the tutorial 5 question 10. The question is, what is the spin-orbit interaction and how does it lead to the observed fine structure splitting of the spectral lines of the hydrogen atom? the relative motion between the nucleus of the atom and the electron creates a magnetic field. Since the electron contains a magnetic dipole moment, the magnetic field will create a torque that will act on the electron's magnetic dipole moment and will orient the magnetic dipole moment along the same axis as the magnetic field lines. This interaction is commonly known as the spin-orbit interaction. The energy levels of a hydrogen atom split by internal magnetic field of the atom, just as the energy level of a hydrogen atom can be split by an external magnetic field. If the magnetic moment of the electron and the orbital magnetic moment of the electron are antiparallel, the potential energy from the interaction is relatively high, but when these moments are parallel, the potential energy is relatively small. Transition from each of these two states to a lower energy result in the emission of a photon of slightly different frequency. That is, the spin-orbit coupling split the spectral line expected from a spinless electron. The fine structure of the hydrogen spectrum is explained by spin-orbit coupling.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afan bin Zaid Zamro. My matrix number is 1180839. And inshallah today, I will present to you about the answer for this question, tutorial 6 number 13, which is about what are the consequences of the fact that the size of all atoms are about the same and what are the reasons for this fact. And for the solution of this question, the size of all atoms are same. It is because atom is made of nucleus which is positively charged and it is at the center, and negatively charged electrons revolve around the nucleus. The size of atom is about 10 to the power of -8 cm, and nucleus is about 100,000 times smaller than the electron cloud. So, the size of hydrogen is same as any other atom like lead, even though lead has more protons, electrons, and neutrons. And the size remains same because the electron tends to screen each other from the inner positive charge, so the size remains same. That's all from me. Thank you very much for lending me your ears.